This is crazy. What exactly happened during SpaceX's Super Heavy Booster 1933 engine static fire test? ULA's Atlas V launches Amazon LEO satellites. Welcome back to the space community. Just a few hours ago, SpaceX's Super Heavy Booster 19 completed its 33-engine static fire test at Starbase. The test, which took place this evening around 6:21 p.m. Central Daylight Time at Pad 2 in South Texas, marked the first time a Block 3 or V3 booster has fired all 33 Raptor, 3 engines at once. Starting just as propellant loading wrapped up earlier in the day, teams at the orbital tank farm chilled the lines while Booster 19 sat secured to the launch mount. Frost patterns formed quickly on the vehicle as superchilled liquid oxygen and methane flowed in, and road closures kept the area clear. Then, right on schedule, the moment everyone had been waiting for arrived. All 33 Raptor 3 engines ignited in what appeared to be near-simultaneous fashion, far tighter than previous stage sequences on earlier versions, unleashing an overwhelming plume of fire and steam that exploded outward from the flame trench. One angle shared by LabPadre captured the instant the engines lit, showing the massive steam cloud rocketing skyward and mixing with bright orange flames at the base. The deluge system kicked in hard, but the intensity still sent huge volumes of vapor billowing in every direction, temporarily swallowing parts of the tower and drifting across the wetlands. The firing itself was notably short, likely only 3 to 5 seconds, and potentially intentional for this first full duration attempt on a V3 booster. Even in that brief window, the test delivered an acoustic and visual spectacle unlike anything seen before on Pad 2. Multiple community cameras showed the booster holding rock steady against the hold-down clamps, while the exhaust gases thundered out. Birds scattered from nearby areas, and a few bits of debris, mostly foliage from the pad perimeter, according to quick assessments, flew outward. Some viewers initially worried about metal fragments near the flame trench, but follow-up comments confirmed it was largely peripheral material kicked up by the blast. The pad itself survived intact, with the upgraded flame deflector and water system doing their jobs despite the unprecedented power. Looking closer at the ignition sequence in slow-motion clips, what made this even more violent, the engines appeared to light almost together rather than in the traditional 3-group stagger used on earlier boosters. This change ties directly into design improvements on the V3 hardware, including beefier transfer tubes that allow for the more aggressive startup. The result was an immediate, unified roar that turned the trench into a roaring steam volcano. With the Plume expanding so rapidly, it looked like it could create its own weather system. Booster 19, now the latest in SpaceX's evolving Super Heavy lineup, incorporates the full suite of upgraded Raptor 3 engines optimized for higher thrust, better throttling, and the kind of rapid reusability the Starship program demands, generating levels of power that eclipse anything previously tested on a single booster. Today's event validated the integrated propulsion system under realistic conditions and gathered critical data on vibration, propellant flow, and thermal loads. Compared to earlier Block 1 and Block 2 static fires that often ran subsets of engines or shorter burns, this one pushed the envelope for the Block 3 configuration headed into Flight 12. With Ship 39 already progressing toward its own testing at a separate facility, the timeline for stacking and integrated operations looks to be accelerating. Engineers will now review telemetry from every engine, chamber pressures, mixture ratios, and post-fire inspections of the thrust section, heat shield tiles, and grid fins before giving the final green light. With data from today's test now in hand, SpaceX's iterative approach, test hard, analyze fast, refine, continues to prove its value. This static fire serves as a major dress rehearsal for Booster 19's role in Flight 12, where it will attempt a tower catch using the chopstick arms after separating from Ship 39 high above the Gulf of Mexico. By the way, if you want quick, deep spaceflight updates, join our community. It's completely free. Just hit subscribe and you're in. Just a few hours before sunrise on April 4th, Another major step in the race to build out global broadband from space quietly unfolded over Florida's Space Coast. At exactly 1:46 a.m. Eastern, a United Launch Alliance Atlas V rocket roared off the pad at Cape Canaveral Space Force Station, carrying yet another batch of satellites for Amazon's rapidly growing low Earth orbit constellation. This mission, designated Leo 5, marked a significant moment not just for Amazon, but for the Atlas V itself, as it continues to push its performance to new limits. From liftoff, everything followed a familiar but finely tuned sequence, the Atlas V 551 configuration. One of the most powerful variants of the rocket provided the thrust needed to carry a heavier than usual payload. With 5 solid rocket boosters and a high-energy Centaur upper stage, the vehicle climbed smoothly through the early phases of flight. Then just 37.5 minutes later, the mission reached its primary milestone, the successful deployment of 29 Amazon LEO satellites into orbit. That number alone is worth focusing on. Previous Atlas V launches for this constellation carried 27 satellites each, but this time, Amazon and ULA managed to squeeze in 2 additional spacecraft. That might not sound like much, but in the world of orbital logistics, every extra satellite per launch matters. According to Amazon, this increase was made possible through detailed engineering work and the use of an upgraded version of the RL-10C engine powering the Centaur upper stage. It's a clear example of how incremental improvements in rocket performance can translate directly into faster constellation deployment. And this launch didn't just set a record for Amazon, it set a record for Atlas V itself. ULA confirmed that Leo 5 carried the most satellites ever flown on an Atlas mission, as well as the heaviest payload in the rocket's history. While the exact mass wasn't disclosed, the implication is clear. Atlas V is being pushed right up to its limits as it approaches the final phase of its operational life. But behind the success of this launch lies a much bigger story and a growing sense of urgency. Amazon's project Kuiper, now referred to as Amazon LEO, is aiming to deploy a massive constellation of 3,232 satellites. The goal is to provide global broadband coverage, competing directly with systems like SpaceX's Starlink. However, the timeline is tight. Under its FCC license, Amazon is required to have at least half of that constellation, 1,616 satellites, in orbit by July. With this latest launch, Amazon has now deployed a total of 241 satellites. That's progress, but it's still far short of the required milestone. Recognizing this, the company filed a request earlier this year asking the FCC to either extend the deadline by 2 years or waive it entirely. The reasoning? Delays in the very rockets meant to carry these satellites into space. Several key launch vehicles that Amazon is counting on have faced setbacks. Europe's Ariane 6, Blue Origin's New Glenn, and ULA's Vulcan Centaur have all experienced delays or limited availability. While Ariane 6 has begun flying Amazon payloads, both New Glenn and Vulcan have yet to launch operational Kuiper satellites. This has forced Amazon to rely heavily on Atlas V, along with a handful of SpaceX Falcon 9 launches. In fact, Amazon has already turned to SpaceX for additional support, purchasing 10 more Falcon 9 launches to help close the gap. It's a notable shift, considering the competitive landscape, but also a practical one, given the urgency of deployment. Looking ahead, Amazon is planning a major ramp-up in launch cadence. The company has stated that it aims to exceed 20 launches per year as more vehicles become available. Future launches on Vulcan are expected to carry at least 40 satellites per mission, while New Glenn could handle 48 or more. Even Ariane 6 is set to increase its capacity once it transitions to more powerful solid boosters, potentially carrying over 32 satellites per launch. If all of that comes together, the pace of deployment could increase dramatically. But for now, Atlas V continues to carry much of the load. There are just 3 remaining Atlas V launches allocated for Amazon, making each one increasingly critical. If there's one thing this mission makes clear, it's that progress in space isn't just about big breakthroughs, it's about consistent, incremental gains. 2 extra satellites on a single launch might seem small, but multiplied across dozens of missions, it becomes the difference between hitting a deadline or missing it entirely.
Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.